Okay, in the previous class, I discussed about the efflux velocity. What was the efflux velocity? Through some orifice or through some hole, the liquid coming out. That velocity is called efflux velocity. And what is the formula for efflux velocity? Yesterday you learned square root of 2gh. Just give one example here. Like this. Yesterday we had done this diagram, but once again, there is a hole, water is falling here like this. So this is what is h? H is this. What is the formula of velocity? The velocity, like this velocity is called velocity of efflux. The formula is 2gh, velocity of efflux. This height of the hole from the free surface of the liquid. This depth or this height is called, this height I am using on here, h. But if question asks you, at what distance the liquid will be striking the ground, this distance, how to find the value of this distance? This distance, how do we find? For finding this distance, we'll take this height to be h, capital H. I think this is like a projectile motion in two dimensions, kinematics in two dimensions. If you remember, this velocity, horizontal velocity, like this, chalk is thrown, this chalk will be falling down in parabolic manner. So this range, how to find the value of range? If you to find the range value will come. The formula of range is V into root 2 this height from which the body is falling down. This height is h, 2h by g. This becomes the formula of range, v into square root 2h by g. This h is this height of the hole from the ground level, from the surface, from the ground. The value of v, if I put this much, 2g small h, and here I will be writing 2h by g. After that, g and g cancels, root 2 will become 2, h and small h. This is the formula of finding range. This is the formula of finding the value of range. R is equal to capital H and small h.
So it's range or range?
Range means the distance, this distance. Range, R-A-N-G, range. Range means the distance. At what distance from the hole, horizontally the liquid will be striking the floor or striking the ground. Done? Yes.
So wait,
No, so
Tell me if you have finished. If you have finished, inform me. Yeah? We can do the continuation of yesterday. Yesterday, till here I derived this formula. From there, you can continue. You can just do it below that.
yes, sir. So finished.
Okay. Finish. Okay, good. By chance, if this height, instead of this height given, we are giving this height. From here till here, this height is given h. Height of the, total height of this free surface of the liquid from the floor is given h. What will be the value of this height? That height value will come h minus h. Capital H minus small h. Then there you will be writing h minus small h. H minus small h you will write. Okay? If the diagram is like this, then what is the value of this height? From here till here, the height will be capital H minus h. But if this height is known, we'll just directly take that height as h. But if this height is given, or let us write this height, I will not write h, I will write this one as y. Anything, y or y. Then with respect to this, the formula will be, or we can write r is equal to 2. This will come, y value will come, this height value will come, h value, capital H value will come y minus h. Here we can write small h y minus h, like this, y minus h. And when we use calculus, there is a topic that we will do in class 12. The liquid will be striking the floor at the maximum distance only when this, this height is equal to half of this at a depth h by 2. H by, okay, no, wait. At a depth, if this height of this one is suppose x, this is x, then at a depth h by 2, water will be, or the liquid will be striking the floor at the maximum distance. This one, just keep information, keep yourself informed, but in higher class you will learn the method, okay? In competitive exam you may get this question. What should be this range for the liquid to strike the floor at the maximum distance, at the largest distance? That value you have to write, remember that x by 2, when the height is the height of the, half of the height of the container. That is when the hole is situated exactly here, exactly the midway of the container, the water or the liquid will be striking the floor at the greatest distance. At the greatest distance. Okay. Now this topic is done. So we'll be doing problems later on. And now give next heading. Third application, right on. Pressure difference. Pressure difference at the same horizontal level, give next heading, same horizontal level. Pressure difference at the same horizontal level. For this we can draw a diagram, okay, we'll take same horizontal level like this way. Like this. Here we will be having diagram like this, and here liquid is flowing like this. Liquid is flowing in this direction, V. V is going like this. Velocity, liquid is flowing like this. Velocity, V is the velocity. Small v is the velocity. Or wait, or here we will take two tubes here like this. One will be here and one will be here. We'll choose 2 points, point A here and point B. Velocity of the point A, I'll take V1. And here the velocity is V2. Can you tell me the points are in the same level, same on, from the ground, no, the height is same, height is same, height is same. Can you tell me which of the points or both the points are having same pressure, or there is a difference of pressure at the point A and point B? Point pressure is different or same? Tell me. Point A and point B, are they having same pressure or they are having different amount of pressure? Tell me.
Different pressure.
The point A.
What that A1? So that written something out there in A.
V1, V2. V1 and V2. Are they having same pressure or different pressure? Tell me.
Different pressure. So different pressure.
Different pressure. Where the pressure will be more, at A or at B? Which pressure will, where the pressure will be more? Which point will get a greater pressure?
Sir, A maybe.
A. Why A? Tell me.
Water column is high.
Sir, water column is
Yes. Yes, water column is higher there than this one, this out here. Here at this point the pressure will be larger. So I'll mark the pressure as P1 and mark the pressure as P2. Out of P1 and P2 we know P1 is bigger. Why P1 is bigger? Because here the liquid column's height is more than the height of the liquid column here. P1 is bigger than P2. Okay. Alright, now I'll find the expression for P1 minus P2, the pressure difference. I'll check that. Okay, now let's see. Bernoulli's theorem, right here. By Bernoulli's theorem, you can write here energy at A, as you know that energy at A equal to energy at B. Tell me what are the energy at the point here, what are the energy? We know always there are three types of energy. You know, what are they? Tell me first. Say, what should I write? Rho G, potential energy, rho G H. Yes? Say fast, respond. Yes. Okay. Kinetic energy like here, half rho V1 square. And pressure energy is P1. Energy at B, that will also be rho GH. What is H? H is the height above the ground. Height of this point above the ground level is same. That's why I gave that same horizontal level. Same horizontal level will have same height from the ground surface. From the ground level, the height will be the same. That is the way I am going to have same potential energy here. Plus, here I write half rho V2 square plus P2. This and this cancels. We know P1 is bigger than P2. No, we know that. So let us make this P1 minus P2 I'll do. I'll find the pressure difference. Like P1 minus P2 is equal to, here I like half rho common, here is like V2 square minus V1 square. This is the value of what? Pressure difference. This is the value of pressure difference. That you can write, delta P we can write here. Delta P is equal to, we can write that is half rho V2 square minus V1 square. So this becomes a formula. This is the formula of pressure difference. Pressure difference at the same horizontal level. This is the formula. Okay, now, have you finished clear?
Yes, sir.
Yes, sir.
Okay. Okay. Now, listen. P1 and P2, out of the two, which is bigger? We know P1 is bigger here. P1 is bigger than P2. But out here, velocity, check the velocity. Which velocity is bigger? V2 is bigger or V1 is bigger?
V2.
V2 is bigger. That means where the pressure is more, velocity is less. And where pressure is less, velocity is more. Wherever the liquid or fluid pressure will be more, velocity of the fluid will be less. And where the pressure will be less, the velocity will be more. So this is a quite important principle given by Bernoulli's theorem, which is used in aerodynamics. There are many reasons and questions we work out on the basis of this fact. And you have observed it also. You know, this pressure difference, what is the use of pressure difference? Pressure difference always creates a force. Pressure difference creates a force from a point of high pressure to a point of low pressure. There will be force acting whenever there is a pressure difference created. That means the body will be moving from high pressure zone to the low pressure. Where the speed is less, it will be going towards the high pressure side. Low pressure side. Low pressure, the velocity of the fluid becomes more. And this is the exact reason of cyclone. Cyclone. In geography, you have studied and you know that when does a cyclone come? When low pressure is created, low pressure zone is created on the surface of the earth, and there will be high pressure on top. So the speed of air where the pressure is high will be less Here the pressure is low. The speed of the air will be high here. And that we call cyclone. And in between the high pressure zone and low pressure zone, why the speed is increasing? Because between them, the force of drift will act. There will be a force. That force will increase the speed and it becomes very high over there when it comes to the big pressure zone. So there will be a force acting between the high pressure to the low pressure in a direction from high to low. And now the fluid or the liquid between them will start moving faster. Speed is less, but now it's picking up the speed. And if the speed becomes maximum or rather very high when it reaches that low pressure zone. So let us find the formula of force of the pressure. Delta P formula is like a force by area. If this is the area of region where the pressure is, force is acting, like F by A is equal to half rho V2 square minus V1 square. Therefore, F value will come because of this pressure difference. There will be a force acting, and then the value of this will become half rho A V2 square minus V1 square. This is the formula of pressure difference, and this is the formula of force, or force between the high pressure zone and the low pressure zone. That force is known as force of drift. The body will be pushed, drifting is swinging, rather you can say swing, like this, swing. Speed is less, it's becoming more, like that. Exactly that happens when the cyclone comes. This is the force with which the cyclone hits the ground. Like, that typhoon, so many cyclones are there, tornado, so many, recently Amphan had come, then Fani had come, so many name of cyclones are there, no? So this is the reason of cyclone. Not only this, there are many reason tag questions also based on this. Motion of aeroplane, motion of helicopter, they all work on this force. They get this force and that force helps them to fly, like drift. Think about the aeroplane. Aeroplane has got fans. The rotor, we call it the rotor, their big fans are there like this. Back side also, front side also, fans are there. What is the role of the fan? The fan circulates the air and keeps the air at high speed. And when the speed, in the nearby the aeroplane, the air is circulated, the speed is high. So the area or the zone near the aeroplane has got low pressure. Because when the velocity is more, pressure is less. Or when the pressure is less, velocity is more. And the other side, the normal air, their speed is normal, so they are having high pressure. So high pressure and the low pressure zone is created. Between them, between high pressure and low pressure, what happens? Force will be acting, and that force makes the aeroplane to fly or to move like this, Exactly that happens. Have you understood this principle? Bernoulli's theorem is only used in the principle of aerodynamics. Aeroplane and all, they all work on the principle of Bernoulli's theorem. The pressure difference is created and this force is acting.
So can you explain again for the aeroplane?
Aeroplane.
Yes, sir.
Okay, this is aeroplane. You have seen in aeroplane there are fans which are called rotors. Have you seen it?
Yes,
At
sir.
the mouth, there is a fan. At the back side also there is a fan. Have you seen it?
Yes, sir.
Yes.
Yes, sir.
Please respond. What is the
Yes,
role
sir.
of the fan? Fan circulates the air. In that area, where the plane is there, this side the air is circulated, the air speed is high. When the air speed is high, the pressure will be less or more. Tell me about that. That area or that zone will be low pressure zone or high pressure zone?
Low pressure.
Low pressure zone. And the other side, this side I'm talking about, other normal side. Air is not circulated. So that side, what type of pressure zone is there? High pressure zone or low pressure? What is it?
High.
Speed is less, no, there. High pressure, yes. Between high pressure and low pressure zone, what happens? Tell me, I told you just now. Between high pressure and low pressure, a force will act. Force will act in which direction? high pressure zone to low pressure zone. From this side to this side, there will be a force acting, and that force will make the aeroplane fly.
Yes, sir. Understood.
Okay.
Sir,
Now I give another one. I think you have seen this in Science City. In Science City, I had also seen it. Science Center, there are two balls here, and they blow the air. There is a tube outside through which the air is blown. This is air. Air is blown in between them. Air is forced in between the two balls. Can you guess what will happen to the balls? Balls will be staying at the same place. Ball will go far away, or ball will attract each other. They will come nearer to each other, near to each other. What will happen? Tell me. Guess. Guess how you think. What will happen? What will you see? Say fast. Come on, tell me.
it will move far away.
It will go far away. Think, or they will remain at the same place. What will happen? You understood the situation, what I'm saying? Through the tube, you are forcing air. Supplying air in between these two balls. There are two ping pong balls, or maybe the plastic balls are there. Once you blow air in between them, what will happen to the balls? Will the ball will go far apart? They will come close to one another, or they will remain as it
Far
is?
apart.
Tell me.
So it will go far apart.
So you are not audible.
Sir is talking to somebody.
So, what will the answer for this question? Say,
So move far apart.
no. They will come close to one another. They will be moving towards each other like this. Why? What is the reason? I'll tell you. The reason is you are blowing air. No, the speed is high or low here. In this region, the speed is high or low. Tell me. In this area, the speed is high or low.
Hi.
High.
High. That is what kind of pressure? Low pressure or high pressure? This is what pressure? Low pressure zone or high pressure? What pressure zone will be there?
Low.
Low.
Low. And other side here the speed is what? High, no? Then what pressure zone will be there? When the speed is high, low, here the speed of the air comparatively is low or low here. Speed is less. What pressure zone will be here? High or low? Tell me.
High.
Yes? High. This side what pressure zone is there? High, no?
Yes, sir.
Yes? Then this will be experiencing a force from high to low, or like this. In this direction, we will experience a force. This will also be experiencing a force from high to low, like this. So what will happen as a result? The ball will come near to each other. Even they may bang with one another. They will be touching each other rather. Understood?
Yes, sir.
Yes? Okay?
Yes, sir.
Now, I give another example. It is not advised to stand near a fast-moving train on a platform. Suppose any express train is passing, it's not stopping there in the platform. One is advised not to stand near the railway track, near the platform, near the train, on the platform. You know what is the reason? This is the reason. Because when a train is moving with high speed, the air in the surrounding area is having high speed, so low pressure. Wherever the train is moving, the pressure zone is low pressure zone. And the other side, the air is having normal speed. The other side, the air is having normal speed. There is a high pressure. High to low pressure in between, what happens? There will be a force acting from high to the low. The person will have tendency to be pushed towards that train. And definitely accident will take place. The one must not stand near the fast moving train. Understood or not? Tell me. Same reason.
Yes, sir. Yes, sir.
Okay, same reason. Now, do you know swing bowling, swinging, balls, swinging and all? Or sometimes the ball pitches on the ground like spin also, and then it drifts. It swings. Cricket bowling, I'm talking about that. Cricket ball. Swing, you know the swing ball, no? Swinging. Some of the boys should be knowing how to swing the ball. Do you know? Does anybody know? Anybody's cricketer a bowler? Is there any bowler here?
So only
No, come on.
footballers.
Only footballers, no cricket bowlers. When you have to swing the ball, you must have seen in TV also, no? When at the time when they swing the ball, they spin the ball in the air like this. They spin the ball with high speed there. And the
Yes,
air
sir.
is circulated much faster. Then wherever the ball is moving up,
spinning
there is
ball.
a low pressure zone. There is a low pressure zone. When the ball pitches the ground, and then due to high pressure zone, the same thing happens. The ball starts flying. The ball starts drifting. And that is known as swing bowling. The same logic behind. So this is a very important principle our Bernoulli Das gave us.
Yes, sir.
The pressure difference will be, yes, and it is very important for aerodynamics. I hope you understood the concept. Okay?
Yes, sir.
Yes, sir.
Today we'll do this much. Yeah. Next day,
Yes, sir.
tomorrow I'll be talking about viscosity. Yeah. Tomorrow the chapter will be over. Okay. Problems are quite
Yes,
short
sir.
here, and we'll finish it tomorrow. Okay. Thank you. Thank you, boys.
Thank you, sir.